So, hello. We have had a chance now to do some practice with a lot of multiplying with binomials. We're going to spend a lot more time now talking about factoring. And factoring, remember, is the reverse of the multiplication. So, reversing the distributive property or FOIL or whatever we've been doing in the past. There is a review question here where it's first reviewing using FOIL or distributive property, however you choose to work that out. And then when we talk about factoring, we're talking about reversing that process. So let's kind of look at this to think about how we would do it in the reverse. In this problem, I'm going to use FOIL. So I would do first, outer, inner, last. So you don't have to do it that way. That's just my preference. And we'll do that real quick here. So 6x squared minus 15x plus the 4x minus the 10, and of course the two middle terms, we can combine those together. So we end up with 6x squared minus, 11x minus 10. Okay. Now think about doing the reverse of that process. So think about going from our answer and going back to the binomial times the binomial. And that is what we're going to start working on for the next several lessons. We're going to be reversing it. We'll start first by talking about factoring when we have a trinomial and there isn't a coefficient in front of the x squared term. That's kind of a good place to start when we're talking about trinomials into binomials. If we look here, if a trinomial of the form, it has to be in this form. If it can be written as the product of two binomials, then the coefficient of the x term in the trinomial is the sum of the constants in the binomials. So we'll talk about what that means. And the trinomial's constant term is the product of the constants in the binomials. So we know that 5 and 10 are constants because they don't have a variable. And we multiply those. That's how we ended up with 10 to begin with. So it's basically kind of going over how you use the FOIL method or distributive property method to get them in the first place and reversing that process. Now let's look at the factored form of x squared plus 12x plus 32 in this example. Well, to write the factored form of this problem, we're going to be looking for two factors that multiply to get 32, and we're going to be looking for those same two factors that have a sum of 12. The book is going to list all the possible combinations, and the bigger the number, if you have a coefficient, the more things you add to the trinomial, the more combinations you could have. So these are probably the easier type examples because we don't have to worry about a coefficient other than 1 in front. So if you look here, they've listed the factors that would multiply to get 32, but have a sum of, in this case, we want a sum of 12. So as we look through those factors, we can see that 4 and 8 multiply to get 32, and they add together to get 12. So right there is our combination. That's what we want. So to factor that one out then, we would say, okay, this trinomial right here is equal to this two binomials. X times x we know is x squared, and we know we multiply 8 and 4 to get 32, and we know they would add to get our middle term of 12x. So that is what it looks like when you're going backwards through the problem, okay? And you can check your answer. If you think you might have made a mistake, you can always use FOIL or distributive property, and you can check. You should end up with what you started with, okay? Let's do one together. Here we're looking, obviously it's still all addition. Again, this is kind of the more basic type of problem, and then we'll kind of build up from here, okay? In this problem, I know to get r squared, I'm going to have to do r times r. So right away, I'm going to write my two binomials, and I'll have r here and r here. And I know they're going to have to be plus. And then I'm going to ask myself, what multiplies, I'm going to write this out here, what multiplies to get 24, but then those same factors have to add to get 11. So you're just going to think about, okay, what numbers multiply to get 24, and which of those would also add to get 11. So we'll kind of look through that combination. I think it's 8 and 3. Yeah. So if I look here, just to write this on the side, 8 times 3 does multiply to get 24, and they do add to get a sum of 11. So that is the combination. Now, when it's addition like this, it doesn't matter where the 8 and the 3 are placed as long as it's in one of the binomials. So I could write it as like this, or I could flip those, and I could say r plus 3 and r plus 8 like that, using the commutative property in a way. It doesn't matter where they are as long as they're in one of the binomials. So either of those work. And usually when we check, I generally don't show or read all the options. You know, you just should know that those could be placed in either binomial. It doesn't matter. You're still going to have the same answer. And remember, we're doing the reverse now of the distributive property. So let's look at another example. And there's a box here, as you notice. Generally, I don't use the box method for these types of problems, but I think it's good for you to at least see one worked out, because we will be using this more when the problems get a little more challenging. Here, if I am using the box method, think of it, it's very similar to the table that we did the other day besides FOIL, but we're doing the backwards table. So we're filling in the inside and we're figuring out what goes on the outside now. So in my box here, the first term, the y squared, would go in this box. And we know that that would be y times y. So that's what would go on the outside of your box. And then we have to think about, 8 would go here. The last term goes here, and those are always diagonal from each other. Then that next step is we have to figure out what multiplies to get 8, but adds to get, it's minus this time. So what multiplies to get 8, but adds to get -6. That does make a difference. So you have to pay attention to the signs. Even I don't pay attention sometimes. So in this problem, we know that 4 times 2 is 8. But if you add those together, they'd both have to be positive in order for it to equal -6. So then we have to think, okay, what could the signs, what's another combination with the signs? So what if we made this -4 and -2? When you multiply those, you still get a +8, but we now can add them to get the -6 or -6. So now the signs have to be -4 and -2. Well, we can use the box. These two would be going diagonal from each other. And again, it doesn't matter the order. They just have to be in the box, and it has to meet that criteria. And then what we do is we go up and we go across, and what we place on the outside is the GCF. The sign closest to the outside also carries. So this negative would carry here, and the GCF is 2. This negative would carry here, and the GCF is 4. So I just wanted to show you how this box method works, and we are going to continue to use it as we get problems with different coefficients and things like that. So my answer here would be what's left on the top and what's left on the side here. And remember, the order doesn't matter in this case because they're both minus. So y -2, y -4, or you could flip those, but I'm not going to do that every time. So that is what I started with, and then this would give me this answer if I use the distributive property or the FOIL method. And again, that's a way you can check to make sure you're factoring that correctly. You don't have to really use the box on these types of problems, but it will come in handy later. So I wanted you to at least be introduced to that, and it's something that you could use now if you want to, but it's something that we'll definitely use more later when we're factoring, okay? Example 3, then, again, they're changing the signs, so we've got to be careful about that. Now, when you have a problem like this where you have different signs, you have to then think about all the possible combinations, okay? And so we have to list some of those possible combinations to find what works. You know what, I think I'm going to stop here just to make sure I have enough time for the next video, because it's going to cut me off here pretty soon. So we'll take a break here, and then when we come back, we'll talk about what to do when the signs are different and what to do when there's a lot more combinations possible, okay?